Hello, good morning, everyone. Let me turn off music a bit because we will be today continue working on the action RPG stuff. So yeah, let's move.
The description below or in the comments below. This video was made possible by the 1-Bit Godot Kickstarter backers. I'll put a link to that at the end of this video so you can check it out if you're interested. And subscribe to my channel, and I will be making the next part probably, I think, next Monday. So I will see you all then. Enjoy your weekend. Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to part 18 for our Godot Action RPG series. In this video, we're going to be adding the UI for the player's health and we'll be adding in the trees as well, just as kind of like a little add-on at the end of the video because it doesn't justify its own video, so we'll be putting that at the end of this one. Let's get started by adding in some sort of a UI for our character. Now we're going to start by making a new node in our world scene here. It's going to be a control node, and we'll have it be a label for now. Okay, so a label is a node. Most of the control nodes in Godot are related to UI elements. So anything with a control node is related to UI. And their position is different from a normal node. You can see they inherit from canvas item. And so they don't have the same type of position. If you come and look at our label here, you can see that we have a layout. Up here, we've got some interesting... I'm going to undo that. What did I do? I made like a red line there.
I don't know,
I'm not
dude.
even sure what I did. But we've got our label here. And this... Oh, I probably moved the origin or something. It might have to do with the label here. But this is our label, and it has some different information here that isn't the same as like a node 2D. You can see we've got an anchor, and that is represented by these little green UI elements here. We can see we're anchored to the top left corner of the screen right now, which is why everything is 0, 0, 0, 0. And you can see we have a margin, which is basically just the size of our label right now. You can see that changing right as we change this size. And we have a rect here, which contains our position and our size and our min size. And control nodes in Godot are very powerful. They have a lot of stuff built into them, but they're also a little confusing. We're going to start simple, and we're not going to deal with a lot of these different properties. They are very powerful, and you can get it, set up to where your control nodes will scale properly and be, what do they call it? What's that word that they use? Like, I don't even remember. But if you scale your screen, the control nodes will scale with it and adapt properly to your screen size.
Isn't it called
and be
auto-scaling?
anchored properly. So there's a lot of power behind them. But this label right here, we're just going to set it up here. We're just going to say HP equals 4.
Okay.
Right? We can save on our game. So now our character has this label up at the top left of the screen that says HP equals 4. However, if we take damage, it actually doesn't change this label right here. So we would have to connect it somehow to our character's health, right? And update that properly. So we can come in here, and to make things simpler, I'm going to actually add another control node. This will just be a base control node with nothing in it really, and we'll put our label as a child of it. And then we'll just leave it like that for now. And we'll call this control node health UI. And we'll actually save and we'll actually instance this as its own scene. So we'll do, where is that? Here. Let's see. Save branch as scene. Here we go.
Okay.
And we'll save it in UI here. Okay. And we'll give it a script too. Attach a script to it. Now the reason I didn't just attach a script to the label here is because we're actually not going to be using a label. We're going to be using some hearts. But for now, I want to show you how to do it with a label. And then we'll change that in a minute to be hearts. But we have the same base either way. So we've got our base control node here either way. And we'll come into our script. What we need to do here is add our own variables here. So var hearts. Well, yeah, we'll call it hearts for now, even though we're just using the label. We'll say hearts equals 10. Wait, no.
That's too
4.
much.
We know it's going to be 4. Set hearts. We're creating a hearts variable, and we're going to have a setter for it. We'll have max hearts. And have a setter for that as well. So, and we'll get access to our label, so we'll just say label here. Label. We'll say function set hearts value. Hearts equals clamp value 0 max hearts. Okay, so when we set our hearts, oops, I forgot to do the colon and tab that in properly.
What is clamp?
So when we set our hearts, we're going to clamp that value so that our hearts are never less than 0 and never greater than our max hearts. Set max hearts. And we'll say max hearts equals max value in 1. So our max hearts can never be less than 1. And we'll have a ready function. And inside of our ready function, we will set our max hearts, self.max hearts equals player stats dot max health, self.hearts equals player stats dot health. Okay, so we're setting our max hearts to be the player's max health and our hearts to be the player's, whoops, this should be max health. Wait, no, health. And our hearts to be the player's health. Yeah, we got it right. We got it right the first time. Okay, and then we need to connect to our player stats. Wait, did we set up the player stats? Health changed? I don't remember if we did. Let's come into stats here. And we have no health as a signal. And that's all we have, right? Yep, that's it. So we need to add a new signal to our stats called health changed. And this signal will be emitted each time our health actually changes. So we'll say signal health changed. And then it will have a new value, the new value that the health is being changed to. So each time we set our health here, we can emit signal health changed, and we can actually emit out an argument with it too, and that will be our new health value, like that. Easy enough, right? So whenever our health changes, we emit a signal saying health changed. Now if we come back into our health UI here, we can connect to that signal. So player stats dot connect. We want to connect to health changed, and we want to do self, connect to ourself, and then what function do we want to connect to? We want to connect to set hearts. And what it will do is it will take the argument from the health changed signal, right? Which will be our new health amount, and we'll pass that argument into our set hearts as the value right here. And of course, this is going to update our actual variable here. So let's run the game here. And you can see I got to kill this bat. It's going to be in the way. Okay, we did get hit once, I think, right? So our label here still shows 4. But if we come into our remote scene here and we look at our health UI, we can actually see that our hearts did update to being 3. So we got damaged and our variable updated to be 3 here, but our label didn't ever actually update. So we need to make sure that we update the label as well. So we'll connect this set hearts function to update the label. Now, you don't have to have your own variables here like this. And if you were just using a label, it might be easier not to just have some sort of, update health label function. And whenever health changed gets emitted, you would update the label. But we're going to actually be setting up this health UI to be hearts. And when I was doing that, it was easier for me to have these variables so that I could actually test them in the editor. But we'll set that now. So we'll come into our set hearts here and we'll just say if label does not equal null, label.text equals HP equals, and then we'll do plus string version of hearts. Okay. Hearts, I did something wrong here. Label, oh, I've got a typo. There we go. Okay, now we're updating our HP whenever our HP label, whenever the player gets hit. You can see now it's going down properly.
Come on. Oh,
and
shit,
we
shit.
die, we're at 0 HP. We're not even using max hearts yet, obviously. But we will be using it. So let's switch all of this now. We've set up our label, but we're going to fix this so that it's no longer a label. But now you understand the basics of how you could update a label like this as well. So we're kind of learning 2 things at once with this. But now we're going to be using a different method, which is, if we come into, we can get rid of our label here.
No.
We have a heart. We're going to add 2 new control nodes, and these are going to be called, we're going to be using the texture rect node. So I guess we could just search it. Texture rect here, okay? And this first one is going to be heart UI empty. This is going to contain the hearts when they're empty, when we don't have any heart there. So come into UI, drag in heart UI empty.png, drop it right here. Okay, that looks good, but we need this to repeat, right? So that when we drag this out, it actually repeats. So come to stretch mode and do tile. Now it should properly tile this as we stretch this out. Right? So we can get more hearts. So we could set it to 4 hearts, for example. And the length for that, we might want to turn off snapping so that we just have pixel snap on. But we can easily set it to 4 hearts like this. Okay. Now we're going to add another one, texture rect, and we'll call this one heart UI full. And we'll drag in heart UI full. And we'll also set it to tile. We'll drag this up here. There we go. And we could set it to 3 hearts or whatever, right? Now you can see how we could manipulate this value right here in order to create more or less hearts. And if we come into the rect here, the size is what we're actually changing. Okay, you can see as I move this, it changes the size. And these are attached to the base health UI node. So if we move
This
move
is
this
interesting,
around, and I
actually.
grabbed it instead of moving it, but if we move this around, they move with it. So we'll be able to position that anywhere we want in the room. Probably want to shrink this down so that it's not as big. Okay, so obviously our label isn't here anymore. We're not using a label for this anymore. We're going to be modifying the rect size of these two UI elements, right? So we'll come into here and we'll say onReady var heart UI full. We'll get access to our heart UI full. onReady var heart UI empty. Get access to that as well. Now, when we set our heart UI, when we set our hearts here, we want to change the rect size of our hearts UI full. So we'll say if heart UI full does not equal null, heart UI full. I have an uppercase U in there, and that's driving me crazy. How did I manage that? There we go. Okay. Not on that one though. Okay, good. Dot rect size dot x equals hearts. So that's our hearts variable right here that we're doing. Times 15. So we're using times 15 because if you come into this texture right here, you can see that it's actually 15 pixels wide. So for each heart we have, for each single heart we have that the character has as health, we need to go over 15 pixels in our texture rect property. Okay, so if hearts is 1, then this is only going to go over 15, which is going to be here. So we're only going to have one heart, right? Our size over here is going over 15. So we can easily set that up.
Let's test.
To properly display the right amount of hearts. And we want to do this.
I still have one, but I already did. I think we're not updating it while after like the player is dead.
Same with our max hearts. If heart UI empty does not equal null, heart UI empty dot rect size dot x equals max hearts times 15. So you could set this up so that this heart system could be applied to other areas of the game if you wanted. That's kind of the point of having these variables up here, is so that you could decouple the player's stats from these actual variables. So this could work without the player's stats, essentially. That's the idea behind it. But you know, if you wanted to, once again, you could set it up to where this doesn't update, or to where this just uses the player's stats instead of having its own variables. Both of those are an option.
I'm dead again.
We need our stats to have a max health change signal as well. Signal max health changed value. And then we need a setter and a getter on our max health. Set get. Well, this is an export variable, so that should be fine. Set get set max health. This is something that I actually didn't do in the reference project, because I don't actually have the player's max health ever change, but you may want it to. Max health changed. There we go. So we're just going to put this in and set it up.
Oh, come on. Can you be just slower now? Max health. Okay, we assign a value to the max health and send in a signal. That's why we need to apply the signal. Max health changed value. Yeah. And I think in this case we need to our control UI, like the parent part, make a bit more bigger, because right now it's just limited to like 4 size of 4 hearts. So I think in this case we should do something like this. How many hearts do we have? Oh, like enough. Enough. Okay, yeah.
There we go. So we're just going to put this in and set it up so that you should be able to change the max health. Now, when we change the max health right here, generally what you'd want to do is make sure that your actual health is never higher than your max health, right? And so you'd have to come in here as well and say health dot health equals self.health, to make sure we call the setter, equals min health max health. So that way our health can never be larger than our max health. If you set the max health to lower than your actual health, then your health is going to drop down and be set to that max health value as well. That's what we're doing.
Makes sense.
And that should then carry over to this as well, but you may want to set it up to do it in here as well. So self.hearts equals min hearts max hearts, like that. The same thing. Okay, so once we have that set up, we can connect to that signal as well. Player stats.connect health max health changed self set max health, or max hearts, I mean. But make it a string here. I can't wait until in Godot 4 they're actually going to have signals and functions have their own types, so we don't have to use strings like this all the time, which would be so nice.
Yeah, that would be nice.
But for now we got to use strings. That's the what we're working with here. So let's see. Art UI empty. This should all work now, theoretically. So let's run the game and see if this works. Okay, we've got an error message here. Cannot use the function min. Cannot convert argument 1 from nil to float. So, okay, I see what's happening here. I was a little worried about this actually because of our export variable. So our export variable here, because our health is an onReady var, it actually doesn't have a value when we set our max health right here, because it's an onReady var. So the solution would just be to, well, we'd have a problem here when we're setting the max health. I wonder if we want to, this is what happens when I branch outside my reference project a little bit. We get to do a little bit of debugging together. So basically what happens here is, because this is an onReady variable right here, and if you remember, we did that so that we could just set our health property to our max health right here, right? So we could say health equals max health. And that does actually work, but the problem is now when we set our health here, if we try and clamp our actual health here, because this variable hasn't been created yet, because this set function is being set right at the start of the game before we're actually calling the ready function, our health doesn't actually exist yet. So we're having a problem here. So we'll just turn this into a normal variable, and then we'll come and we'll make a ready function down here and just
I
say
don't mind.
self.health equals max health. In the ready function. And I think that'll work. Yep. And now our hearts are...
Yeah.
Oh, it didn't update when we died. That's interesting.
Yeah.
It should have. Okay.
No, it's not. No, it's not.
We'll have to figure out what's going on there. Now the question is it the hearts? Well, let's actually use our remote inspector again, because that should give us a really good indication of what happened. Let's come into our remote inspector and we'll look at our health UI, and we can see these variables here, and we can see that hearts has been set to 0. Okay. So our hearts have been set to 0 properly, but the UI, our full here, hasn't been properly set to 0. So let's see what happens when we come in here and we set our size to 0. Okay, that didn't work. It set it to 15 here. So there's a problem. The problem is that we can't actually set this to 0. The size, it's not letting us make it smaller than 15 here. And that is a big problem because we want to be able to set it to 0. So if we come into our size flags here, I think the solution is to set this to expand, if I remember right. Let's see here. Let's try setting it to 0 now. No, it still didn't work, so that wasn't the solution. So expand here will allow us to have this control nodes will expand to try and fill the control node that they're in. And so when we set this to expand, it would try and fill up the parent control node that it was in. Let's see here. Hearts UI full.
Maybe
so,
shrink N
let's see,
should
what was
work.
it? Oh, it was expand up here, actually, I think. Was that it? That was it. Okay. Yeah, so I got the two expands confused. So this one right here will make it try and fill up the space that it's in. This expand up here is actually a little bit less. It says the texture scales to fit its bounding rectangle.
It is working.
Which makes it seem the same. So I'm going to be honest, I don't actually understand this expand right here as well as I do down here. And it's kind of interesting that they both have the same name. This one I've used in multiple places and I have a better understanding of it. And I'm not going to go into the exact details about what it does. I think I want to do a Godot series that kind of goes into control nodes. They kind of need their own series. They're rather complicated, powerful, but they're not easy to use, and they feel a little bit counterintuitive at first. But up here, this expand, I haven't really used that often. All I know is that if I set this, then I'm able to actually set my size to 0 properly now. It won't default to 15. So you'll need to have that active. So then let's run the game again. Script. Inside of the ready function, well, actually, let's just go into our player's stats. I want to try setting our player's max health to something higher. So let's set the max health to 6 or so. Save the game and run. And there we go. Now we have our player has 6 health. You can easily set the max health value like that. Let's set this back to 4. Save. We still get this interesting error here for the editor that I never quite figured out. Nobody really knew what that was. I think it's just an editor error here. It actually won't affect our game. Let's close out of our player stats. Let's come back into our player now. And inside of our player, what I want to test here to make sure that this is working properly is we'll make it so this doesn't make any sense, by the way, but each time we roll,
Okay.
let's set our player stats dot max health minus equals 1. So I want to make sure that this properly updates the parts. Oh, darn it. Oh, I managed to kill it without getting hit. Okay, so if we roll. Okay, so it did set our players. It set our heart down less 1, but it's not actually setting the max health properly. And we're getting an error here, so I'm glad I tested this. It says, error calling method from signal, max health changed. Method expected 1 argument, but called with 0. Okay, so let's come into that. Okay, so this is where we went wrong. You can see when I emit the signal inside of our stats, I don't...
Hold on. Where do you emit the signal? It's player, it's stat script, okay. Yeah.
actually send out the new value like I do here with our health changed. So we need to make sure and send out max health right here so that that gets updated properly. We can save, we can clear this right here. Run the game. Get rid of this bat and roll, and there we go. Now we can kill ourselves, but we're never allowed to actually set our max health less than 1. So it does leave the max health at 1, which makes sense. It never actually gets rid of the UI, which is what we intended. But you can see we are able to set our max health to be less, or if we have our player, we can actually increase the max health as well. And that doesn't give us health, right? It just increases the max health. And the reason it lowers our actual health is because we set up for that use caseage where you could potentially have less, where you would never want to have more health than you do max health, at least in the game that we're designing. Now you could make this go off the screen and it won't properly. Okay, and we'll save. So our health bar is working properly. Let's quickly make a new scene for our tree.
2D.
Come in here, we'll do a 2D scene. We'll actually delete that. We'll make it a static body. This is going to be review a little bit here. Just like our bushes, do a static body. We'll add a sprite or like this. Come into find our world. Come into grab our tree. And we'll want to move it up so that we get it centered better on where we want the where we want our origin for the Y sorting to be. Then we'll attach a collision shape. Collision shape, and I'm going to use a capsule. I'm going to rotate this capsule by 90 degrees. Drag this in and move it up a bit. Something like that should probably be good. And we're going to add another sprite.
The fuck? Hold on, dude.
This will be our shadow.
Ooh.
And I think we need the big shadow for this. So where did I put sprites? Or the shadows? Are they in? Oh, I have a shadows folder.
Large
We'll use a large shadow for this. There we go. Our tree has a nice shadow now. Save this inside of world. Save. Come back here. Got our grass and our bushes. So let's create a new YSort node. YSort. This will be for our trees. And we'll instance some trees on this node. Probably only do 1 or 2 trees, because they're big. 3 scene, drop it here. 3 scene, maybe I'll drop this one up here. Call it good. Make sure the collisions make sense and they work with Y sorting and such. Okay, looks great. Our bushes don't have shadows either. Let's actually add shadows to everything. Bush.
No,
Here we go.
I'm already dead.
Add a sprite. Make sure it's above our other sprite here. Shadow sprite. Come into shadows. Do a medium shadow for this one. Wait. Maybe I did a
it's
large
too
shadow for the bush
small.
actually. Oops.
Mm,
If you hold Alt, you can make sure and select the one that you currently have.
We can make it smaller.
I guess I did medium shadow or large shadow for the bush, it looks like. Or maybe I didn't even do shadows for the bush. I don't remember. But there we go. Now our bushes have shadows as well. Let's give our player a shadow. Come in here. Add a sprite. Drag it up here. Shadow sprite. And I think I did medium for the player. And then hold Alt. Drag it down. Let's see. Maybe to there. I think I moved it down only 1. Now our character has a little bit of a shadow too. There we go. Ah, that is killing me.
Yeah, this
Now
is
we've got
weird.
our
The shadow is
Parts up there
over
in the top left-hand corner.
main sprite. Yeah, so I need to replace it actually. Shadow sprite. And you will go on top. And I think in this way it shouldn't be that disgusting. Yeah, it's better now. Fuck off. Oh, come on. Oh, shit. I'm dead.
We can actually move them down. So let's grab them here. Move it down just a bit.
Yeah.
I'm going to turn off snap. I'd rather have it positioned somewhere like here. So it's just a little bit inside from the corner. And these hearts will not follow you around in the view. We'll be handling that later when we add the view and such. So if you were to add your own camera to this game, these hearts won't follow it. But we will be solving that when we add a camera. So that's going to be it for this video. Thank you so much for watching it. It was made possible by my 1-Bit Godot Kickstarter backers. I'll have a link for that in the description. If you enjoyed the video and learned something from it, be sure to give it a like, subscribe to my channel, and I will talk to you all later.
Okay, moving on to the enemy.
Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to part, 19 for our Godot Action RPG series. In this video, we're going to be solving a problem that we have where if you have 2 bats that are chasing you like this, they can end up overlapping each other, and it looks like there's only 1 bat here because there's no real way for them to collide with each other. So we're going to be implementing a soft collision system into this, and it's a system that I used back in my GameMaker days when I was using GameMaker all the time, and it works in Godot as well. So we're going to start by creating a new node. It's going to be an area, 2D, and this is going to be our soft collision component. We'll just call it soft collision, and we'll give it a collision shape. And we'll save this in overlap. We can save it. Well, yeah, I guess that's a good spot to save it. It makes sense to save it there. And we'll attach a script to it. It'll be called softcollision.gd, and we'll
Come on, wait a second.
And we'll save this in overlap. We can save it. Well, yeah, I guess that's a good spot to save it. It makes sense to save it there. And we'll attach a script to it. It'll be called softcollision.gd, and we'll come into here. And basically, the only thing this needs to do is it needs to detect whether it's overlapping something, and then get a push vector. So a vector that kind of pushes away from anything that it's colliding with. And so we can use that push vector to move our bats outside. If they're overlapping each other, we can push away. They'll push away from each other and move away from each other.
Push away, move away.
So we'll make an is colliding. And the way we can tell whether or not this is colliding is if you come into your area 2D right here, you can see we have some different methods here. And we have a get overlapping areas right here and a get overlapping bodies right here. And these return an array. So obviously they return all of the areas that you're overlapping with or all of the bodies that you're overlapping with. And so we can use that right here to determine if we're colliding with something. So var areas equals get overlapping areas return areas.size is greater than 0. So if we'll get the overlapping areas, and this will be an array, and if that array's size is greater than 0, then we're colliding with something, so we return true. Otherwise, it'll return false. Now we can make our get push vector function here. We'll say var areas equals get overlapping areas. We'll get the overlapping areas again. We'll create a push vector variable here. We'll just set it equal to vector 0 for now. Vector 2.0. And then we can check to see if you could call is colliding here again, actually. And we might do that. We could do that. If is colliding right here, then we can do var area equals areas 0. Oh, yeah, that's right. Area 0. So what we're going to do, we're going to get the first area that we're colliding with, and we're going to ignore the others. And that actually seems to work pretty well. And it helps optimize it a little bit. So we're not looping through every single area that we're colliding with. We're only worried about one of them. And even though we're only getting one of them, it happens often enough that we're able to account for that anyways. So if we're colliding with two areas, we'll move away from one of them, but then they'll also move away from each other. And so it works out in the end. So our push vector will be equal to area.global position. And that's the area that we're colliding with, right? Its global position, direction to our global position. So it's basically we're getting a vector that goes from its position to our position. So that's let's open up paint.net here again. I can show you. So here's us. Here's them. We're going to get this vector right here, no longer overlapping. We want to normalize that push vector. So push vector equals push vector dot normalized, which once again, our vector math here, we'll take that vector and make it a length of 1, whatever that is. And then we can multiply it by however and do return push vector. So this will return 0 if we're not colliding with anything, right? We might check is colliding up here. So we could actually do this. No, let's just leave it this way. We'll leave it this way. Okay, so now we have our soft collisions. Let's come into our bat right here. Come into the bat. And we'll add a soft collision to our bat. Oh, the other thing we need to do actually, before I forget, is come into our project settings, and we need to set up a physics layer for soft collisions. That way they don't collide with everything else in the game. come into your soft collisions, and we'll set it to be both the layer that it's on. Wait, which layer is this? Soft collisions, and the layer that it's looking to. It's going to be both. Okay, save. Then we come into our bat. We can instance a soft collision on the bat like this. And we need to set up its collision shape.
Yep. Editable
And we're going to
children.
use right at the base here, right down here. So we'll do editable children, make a new little circle, and shrink it down so that it's pretty small. Doesn't have to be very big. You can make it whatever size you really want to. And we're going to actually hide a bunch of our colliders here, because they're starting to get a little bit distracting in our editor. And just hide them all and save. Now we can come into the bat and we can use those functions that we just created in order to move the bat, because all those functions do is they get whether or not the bat is colliding with another soft collision and what the collision vector should be if we are. So now we actually need to do the logic for moving, and we'll do that inside of the bat. So make an onReady var soft collisions, soft collision, and we'll get the soft collision. And then right here, right before we move, right before we update our velocity, we can just do if soft
I'm so sorry.
collision dot is.
Hold on. Where you moved?
And right here, right before.
Okay, when we apply velocity. Why do you? Why it's in chase? Okay, it's in chase. Yeah, that makes sense.
Before we move, right before we update our velocity, we can just do if soft collision dot is colliding. So we want to make sure that we're colliding. Then we say velocity plus equals soft collision dot get push vector times delta. Want to make sure we're multiplying it by delta, and then multiply it by some value that will make sure that they push outside of each other. And the stronger this value, the higher this value is, the less likely they are to overlap at all. And now we can see if we can get these bats. You can see when they get next to each other, they don't actually ever overlap with each other. They stay outside. And we can actually, I think it'd make sense to make our soft collision shape a little bit bigger than it currently is. Yeah. So they stay a little bit farther away from each other. We'll try that. Whoops. And now you can see they stay pretty far away from each other. And if we go into our player here, and we come into our hurt box, and we uncheck our layer, we shouldn't be able to be
me all the
damaged
time
by the bats. So we can get them all overlapping with each other. And see that in action. See, they do chase the player.
Oh, he's running away and didn't receive any hit.
Now this system is, it's not really the most, I wouldn't recommend using this system if you're going to have hundreds of enemies on the screen at the same time. However, I did do a little bit of testing myself to see, and if you duplicate a bunch of these, I want to show you this because I feel like this is really useful, right? We get a ton of bats on the screen at once. I don't know how many this is.
Okay, I want to do the same.
But maybe you want a game that has quite a bit of bats. Okay. and save and run the game.
Mm.
You can see that it seems to work okay, right? We're not getting huge frame drops here. And so it can handle quite a few different enemies, at least if you're targeting PC. If you're targeting mobile, you might want to come up with a different, more optimized system. And there are ways that you could slightly optimize this by setting a timer potentially, so it doesn't check the collision every single frame, and other things like that. You could look into using a Boids system, because Boids are a pretty common way to handle this, and this is similar to a system like that. But let's actually look at our performance, because I want to show you guys how to do that. So if we run the game, I'm going to move the game, come down into debugger, and if we come into our profile, if we come into monitors, we can monitor our performance, because this is similar to a system like that. So if we run the game, I'm going to move the game, come down into debugger, and if we come into our profile, if we come into monitors, we can monitor our frame rate here. And you can see we're holding a strong 60 frames per second here. It's interesting. In my other one, it actually shows, and I'm gonna, on the other screen, I'm actually gonna attack the bats, hit them. Okay. We dropped down to 58 for a second there, but it's pretty much holding strong at 60. So you can also come over to your profiler, and if you were trying to determine, like let's say you were having big frame drops and stuff like that, and you wanted to determine where that was happening, you would use the profiler for this. So what you do for the profiler is you start right here, and it profiles the game for a little bit while, like this. And then you could choose which things you wanted to profile here. You can see our git push vector is included in here.
No, what's happening?
And then you would
here?
stop, and you would get data, and you can go to any frame here, and you can actually look to see what functions and what areas are costing the most amount of time. So you can see that our, let's see if we can find, here's our git push vector right here and is colliding. You can see that they are having a lot of calls right here, but we're still doing okay with our total time here. So this is, if you were having big issues with optimization, this is where you would figure out why and where that is happening. So like, what if we turned off the physics frame and we said, okay,
really
let's
nice
check our
tooling.
git push vector and see, you'll obviously see that if we start this here and we have a whole bunch of enemies, we're going to get a lot of stuff, but then over here on the left, I'm going to kill the enemies. And it's going to drop down because we're not going to have as many things actually attacking. Well, it didn't seem to make too much of a difference, actually. So, well, it's not even calling it at all now, I don't think. Let's see. Oh, it did go up a little bit there. Obviously, I killed all the bats and then made these two start interacting with each other again. When I move the screen, we get drops. That's interesting that moving this around gives us a frame drop, but that's probably normal. Anyways, this profiler is how you would determine where you're having issues in your game. Actually, this is less time, I think, that it's taking to call those functions. I understand this properly. I do wish there was some sort of an indicator over here on the side as to what
the
these
FPS goes
actually
down.
mean. Like, is this how many calls there are? What is this number here? I'm not actually sure now that I'm looking at it. It makes a lot more sense with the frame time. I'm guessing this is the milliseconds. Yeah, it's up here. Frame time in seconds right here. So that's what this is showing right here. Anyways, there, you learned about your profile of this one. Oops. Back into world. move this one over just a little bit so it doesn't attack us. Somebody mentioned that. They're like, you should move that bat so it doesn't attack you every time you start the game. But yeah, now we've got a good system set up for our bats so that we can handle overlap, and it does pretty well handling a lot of enemies on the screen. And that's going to be it for this video. Let me make sure that we set our player's hurt box back to be the proper collision layer. That way we can take damage from the... you should already know. And if you're interested in my 1-bit Godot...
Okay, player camera.
Good morning, afternoon, or evening, wherever...
Not sure I will have time to actually... Okay, it's 7 minutes
you
now,
are,
we
my
can
name is
finish
Benjamin,
it.
and welcome to part 20 for our Godot Action RPG series. In this video, we're going to be adding in a camera that will follow our character around. And this is actually going to be the second to last video in the series. The next one will likely be the last one. So we're getting close to the finish here. We've learned a lot. It's been a lot of fun. Let's get started. Come into your world, and we're going to attach a new camera 2D node to our player. And once we do that, you can see we get this little border around the player like this. And
Wait, what?
but this...
Hold on, this should call trees. And we should add camera 2D.
little border is really thin. It's kind of hard to see. And so if we run the game also, the camera doesn't actually follow our player still. So, and it's not even actually running, basically. This camera isn't actually even being used. So in order to use this camera, what we need to do is turn on current. If you come over to its properties, that increases the border here, makes it thicker. And then when we run the game, we can see that the camera now follows our player.
Nice. Finally.
Okay.
Fuck.
So we also are going to want to increase our background size here. Something like that. Maybe.
Yep, like this.
Got it centered, so that's a bit odd, but that's okay. That works for now. We'll save. And
no, where is my horse? The horse is not moving.
So now the camera follows our player around. It's pretty easy to set that up.
What the fuck is going on with
the camera
horse
feels a little bit harsh because it follows our player exactly. And you can see that our hearts don't follow the camera right now. Also, if we die, the camera gets destroyed. The camera that is attached to our player also gets destroyed. So then it resets to the default camera. It looks a little bit awkward, right? Like if we run the game and we come clear over here and have this enemy bat kill us, then the camera jumps clear over here when we die. So we need to fix some of these problems. So the first problem that we're going to fix is the hearts. We want to make sure that our hearts follow the camera. And the way that you do this is by creating a new node and creating a canvas layer node. So the canvas layer node, this node will follow the camera around on the screen, and then we can set our hearts or our health UI to be a child of that canvas layer node, like this. And then when we run the game, that's all you have to do. The hearts now follow the camera around properly on the screen.
That's really easy.
Now the camera being a little bit jarring is an easy fix too. We can come into the camera properties and we can turn on smoothing.
Wait, what? Wait, what? Okay. Okay, I see, yeah, it's slowly. That's fine. That's a good one.
And you can see now the camera is a little bit less jarring when we're moving around in the room. And you can play with some different properties in the project settings as well. Some people prefer the look with, so there's a couple things to keep in mind if you feel like your camera is a little bit jittery. And so part of the reason that the camera can be jittery is because the camera is moving at a sub-pixel amount. So it's moving less than a pixel at a time. And I don't mind that look for this. Like, I think this looks pretty good, and you're never going to get anything 100% perfect. But there are a few things you can consider. Number one, you could consider setting your camera's process mode to be physics. That way it updates on the physics frame, which would, if your player is moving on the physics frame, then it would match the player. I personally prefer the look on the idle frame. I don't really see much of a difference between these two, actually. You can also check in your project settings to your rendering. Where's our rendering? Quality. You can turn on use pixel snap, and this should theoretically make your camera snap to perfect pixels, and that's a completely different look as well. And so that might be something you want to consider too. So I prefer just kind of the default settings for it, and I'm not going to go into some different solutions, because I'm sure there are other solutions to these problems as well, but those are kind of the ones that you might try for yourself, see what gives you the best result, and stick with that. So now that we've got camera smoothing on, the last thing we need to fix is the issue where our character can be, when the character gets killed, the camera jumps clear back to here, which just looks super awkward. So the way that I've ended up solving this problem is by moving the camera outside of the player, right? But that means that the camera will no longer follow the player, right? If the player moves, the camera no longer moves with it. Now you could use a script and attach it to the camera to make it follow the player, but there's a node you can use for this too. So let's attach a node to our player. It's called a remote transform 2D node. And this node, what it does is it makes, you give it a path to a different node, and it makes that node follow it. And so we want to assign a path and choose our camera. And now, whenever this remote transform node follows our player around, the camera will follow us as well. See, it follows just like it did before. However, if we end up dying over here, then the camera isn't being destroyed. The camera is still in the game. It's just no longer following the remote transform. And so now the camera stays where it was when we died.
Like, this is so easy.
And that's going to be it for this video. It's a really
it's
short video, but I think it has some useful little things to learn, like the remote transform and using the camera to get on with these our game in, make it significantly closer to the player, and you can mess with those properties as you see fit. So if we do 1.5, that's going to be a huge camera for our player, kind of zoomed out pretty far. And you can play around with those. So I think we learned some cool stuff in this video. I hope you enjoyed it. If you did, give it a like and a thumbs up, or subscribe to my channel, and I will talk to you all later.
Cool beans.
Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin,
and
welcome to part 21 for our Godot Action RPG series.
This will take a while.
The final video. Holy cow.
It's not final video. Sounds, and then hit flash effect, and only after camera limits and herd box fix. So that's still a lot. I hope we will finish this action RPG stuff this week, and maybe by the end of the week I will have enough time to actually start moving my own prototype to Godot. So yeah, I just wanted to check how it looks like right now. Yeah, but this is really useful. I learn a lot of stuff with the Godot, and the Hard Beast tutorial is just insane. he prepared like so many information. Like even the small video, it's still really useful. I think this is like one of the best tutorials. So yeah, I am totally recommended to anyone who try to learn Godot. This is probably the best way to learn it. Okay, so I hate Unity, and Unity hates me. See, it's trying to open the project. Okay, let me turn the music back. Nice. No, I need to put myself a little bit lower. Nice. Okay, there we go. Oh, come on. What? Why it's black? Every single time I open in my project and I have no idea what's going on it because it looks like it's everything again broken. Why the hell are you broken? Okay, it says, oh no UI, something is broken, please help me. Oh, come on. I don't open the script. I don't want. Ah, crap. This is a crap. Yeah, it's not gonna work. Okay, not today. Probably not today. Okay, then I will be finishing my stream. So see you.